Alright, welcome to the last math refresher, the optional math refresher, and we'll be looking at statistics. Yeah? So we'll cover a lot of definition in terms of statistics because we will need it when we talk about these algorithms. Just a few here: sample space, random variable, probability distribution, what is Bayes rule, very important Bayes rule. What's the expected value of a random variable, what's its variance. Then we'll look at some famous probability distributions, Bernoulli, which is the time cost. We'll have Gaussian and binomial distribution. We'll finish with the weak law of large numbers and the central limit theorem. We'll take a look at what a covariance or a variance matrix is. Statistics is key, as I mentioned, for classification. So let us try to formulate what the issue is. So here you have a classification problem, and it's a binary classification. Binary meaning you have two possibilities: y is 0, y is 1. So I give you a point, and you need to tell me if that is y is 0, y is 1. One item could be a brain scan. If the computer looks at the brain scan, he can decide y is 0, no tumor, or y is 1, tumor. Yeah. Basically what happens in a classification problem is I get a data set, right? I get a data set where I have the feature as well as the label. This is a training set. Yeah. This data set is drawn from a distribution. Yeah? A distribution of y given x. Yeah? The thing is that in a classification example, we do not know p of y. It's exactly what we want to determine. Yeah? Let me give you an example here of what we would like to have. So here you have your p of y, yeah, given x. For example, these are 3 brain scans, and they have been classified as y equals to 0. These 3 have been classified as y equals to 1, and these 3 again y equals to 0. So if I take a test point, let us assume that is my test point, x test, and I have this distribution, I can basically derive that x test is gonna give me a label of 1. Yeah? Now if x test is here right on the edge of y is 0 and y is 1, then it becomes a little bit more complicated. Yeah? But basically the whole classification theory is, how do we predict the label y? Now, p is probability. How do we predict y? And then the /x means given x. That's a conditional probability, and we will see this. Yeah, we will see this very shortly. Just wanted to give you the high-level overview of what we're trying to do.